All right, those who are in video land, we are looking at a preparation more for our test tomorrow. And over here on the board, can you get this? Are the answers to the multis that came home yesterday. They weren't required, but they're always good for us. And I also put up on our website, our old website, explanation for these 9. I did address 10 slightly. I just said don't do it. So 1 through 9 basically. So if you have done those and you have questions about one, we're not going to take class time to answer those questions. You can go to Videoland and have them answered. All right, pull out 8.2a. We're going to go over that now. Go ahead, Trent. I can answer your question.
No, I'm finished.
Oh, yeah. Okay, very good. Okay. Did you mark which question?
Oh, no.
All right, you have to pick a question. All right, are you want to do that tomorrow?
I can do it.
Okay.
Trying to make it a feature in our video.
It's okay. All right, number 1 on 8.2a. I'm going to just go over them quickly, and as I go, just don't even raise your hand if you have a question. Just mark it, and at the end, I'll answer your questions. So, all right, 8.2a. So the question talks about a simple random sample of 1,100 males of a given age and asks whether they play this kind of game online. And we want to use the information to construct a 95% confidence interval to estimate the true proportion of all U.S. males who do this in that age group. The parameter of interest is P, the percent of everyone in the United States who play in this age group, the percent of males 12 to 17 in the United States who play this game. Identify each of the conditions. So we're looking for RIN. So R is random. It was given as a random sample. I took the number 1,100 and multiplied it by 10 to check the 10% rule. And I just assume that there are more than 11,000 males in that age group in the United States. So I checked that off. And for, do you have yours? Yeah, you do. Never mind. Is it normal? So this is proportions we're looking at. So here's where I had you put that up on the board. So we had to do a test to see if n times p was greater than or equal to 10. And n times 1 minus p. When we're looking at a proportion, we have n is 1,100, and proportion is, where's that number? 775 over 1,100. So when you multiply, the 1,100s cancel out, bless you, and it leaves you with 775. That always will happen. So the number of successes greater than 10 and the number of failures greater than 10. So we have 775 is greater than 10 and 325 if you do it the other way. So it passes the RIN test. We're asked to find the critical value and the standard error. So it's like we're beginning to build the confidence interval. Since it's 95%, we know, we used to think in the olden days that the critical value was 2, but I learned that the real critical value is 1.96. And if you had forgotten that, you'd have to draw the 95% under the curve, and you'd have to recognize that 5% is in the tails, half it would be over here, so half of 5 is 2.5%, so that is the number 0.025 in the body of chart A, and that will bring you to the number 1.96. So 1.96 is the critical value working backwards from chart A. And to do the standard error, you have your standard error right here for proportions. So I put in, I think I put in 0.7. It's pretty close. Where did I get that? 775 divided by 1,100. That's how many said yes. They played the game, and that was about 0.7. I rounded a little grossly. 0.7 times 0.3 over 1,100 and square rooted it. When I did that, I got 0.0138. If you round it a little less gross, you should still be near that number. All right. The confidence interval then, putting it all together, we're doing one of these now, this whole thing. I ended up with 0.673 and 0.727, so about 67% to 73% is the amount that we are confident it should be. Well, they'll probably ask us to interpret it. Yep, they did. Predictable quizzes. Interpret the confidence interval. So we are 95% confident that the true proportion of males who play this game between 12 and 17 years of age in the United States is between 67 and 73%. All right, on the back. Suppose you wanted to estimate the proportion of 12 to 17-year-olds who play this game with 95% confidence to be within 2%. Calculate how large a sample you would need. So we messed with that previously. So you had to actually take the margin of error. So that's going to be this whole thing in the rectangle. And you're going to have to take Z star, square root, p hat, 1 minus p hat, divided by n, is less than or equal to what they say, 0.02, and solve that with these numbers, which we got from the front, 1.96. I used 0.7, 0.3 over n, which was 1100. Has to be less than 0.02. Oh, sorry. They want to know how many. Sorry, I forgot myself. So they want to know how many we should use to calculate, should you want to estimate within a certain margin of error, how many should be in our sample. So when I solved that for n, I got n had to be greater than or equal to 2016.01. If your number's different, it could be from rounding. They change a lot if you round differently. So that means n will have to be 2017. We always round up on these. 2017. If we round it down like the rules of math would ask us to do, then we will not be within this margin of error. It would be slightly outside of it. So you always want to give the company the benefit of the doubt and round upward. I think the book got 1998, so if you got something...
I got 2033.
Yeah, it's all a rounding thing. I should have carried more decimals right here, and so I'd like to hear when I finish what other numbers you got. If you wanted to have a margin of error with the same margin of error but 99% confidence, so we went up from 95 to 99, would your sample have to be larger, smaller, or the same? So you could actually do the whole calculation again by using a different Z star, the one that corresponds to 99%. And I looked that up. I actually did it just for fun, and I got 2.57 with Z star when I used 99%. And so therefore, when I did that, the whole interval got larger because this number is larger. But you didn't really have to calculate it. You could explain it. Otherwise, we have learned that as n gets larger, let's see, what is the question? I'm lost.
Margin of error.
Oh yeah. Well, if you wanted to have a margin of error, confidence interval went out, would your sample have to get larger? And we learned that it works. We learned that as n gets larger, the confidence interval gets smaller because we can go in closer. So how does that work with this?
The margin of error also gets smaller.
It does. Because I just said that this number gets bigger, so this whole thing does, but it doesn't because we're looking for n. And so n is in the denominator, so everything works opposite. So mathematically, if you increase this number will actually go down. So we are going to say that to increase your confidence, to go from 95 to 99, so we're getting a less precise. We're going to widen it, so n would have to be smaller, wouldn't it? What?
No.
So,
So this is what I have.
Little tiny
Okay.
doodle.
I thought it
So
would be opposite.
margin of error gets smaller as confidence level gets smaller. So as
margin of
when-
error
when-
gets smaller as confidence, yes, okay.
So when confidence level increases, then margin of error.
Alright, so what
Also
happens
increases.
to n though?
And I tried to catch it. and I
But
hit
when
it,
margin of
and I looked
error
at my hand, and I can't find it.
decreases, then sample size
Gone.
increases.
Decreases, right.
So if margin of error increases and sample size decreases.
Alright, I think that's what I said. Alright,
Wait.
Smack it.
alright, well, let's try it.
I'm-
1.96.
I think I just wrote the wrong thing.
0.7 and 0.3 divided by square root of n is less than or equal to 0.02. I know from the previous one, I got an n of 2017. You got something like that. So now I'm just going to do it again and see what happens to n. All right, so I'm going to move this over here, 0.02, and this over here. I think I did that last night, but I don't have the number in front of me, so I'm just going to pull it up right now. Alright, so I got 1.96 times 0.458 divided by 0.02. So I get 44.9 is less than or equal to square root of n. I like to flip that around, and then I have to square that. So my n, when I did this one, came out to be 2017. So now when I do this one, 44.9 squared, I get 2016. It wasn't very much different, but it was.
Yeah, I got what Ryan got. Ryan, you
I
got
got-
2033.
Yeah,
I got sample
2033.
size gets smaller
Yeah, sample size gets smaller.
because margin of error gets smaller because confidence gets bigger.
Right, right.
Yeah, that makes sense.
This
If you're
whole
more
thing-
confident, then you're going to have less error, which means that your size is going to be
Closer to the population size.
yeah, like more narrow, more right.
Wait, so the margin of error goes up with the sample size, right?
Yeah, and also down with the sample
Wait,
size.
so your answer
Wait.
was 2016?
Your sample size
I
and
got
margin
that.
error are on the
No.
same.
But
Well, you
what
have to
y'all
round
get,
it.
what you all get for the first part? Well, you didn't have to do this mathematically.
I
So
got didn't you have 216.01? That's like barely bigger than
I
that.
know it isn't. That's what I got.
That is really.
I got a lot bigger.
Oh, I know why. Because it's the same one. I didn't put in the 2.57. That's why.
Nice, pal.
I don't even remember
All
how to do
right,
it.
all right. I
Yeah,
did
the other
same-
one is a lot
I
bigger.
did the same calculation. All right, so I have to pick this number up right here. All right.
So now it's
We'll find out.
2.57.
All right, so now 2.57 times 0.458 divided by 0.02. All right, 58.8, that's better. All right, so now when I square that, I get 3463 for n. So n went up. Is
Which
that
doesn't
not what we
fit the chance.
expected?
And no, that's not what we expected.
Oh.
No.
Yeah.
Okay, no, that's what we expected, but that's not what we were looking for. Wait, what? I'm so confused.
What's your
Margin of
sample
error
Right, what do you think?
stays the
They're
same.
asking the question, should your sample be larger or smaller?
Larger,
If you
that's
were
right.
increasing your confidence from 95 to
The
99.
confidence cannot get larger if the margin of error stays the same. That's the real problem. They're saying that your margin of error is the same, but your confidence grows.
That's
Yeah, because
okay,
you're-
because this number will stay the same, but this number will change. Confidence is related
Because you're
to the
covering
Z
more area
star.
when you increase your confidence. You're covering more people.
But
Yeah.
shouldn't that change your margin of error?
Yeah.
No, because it's giving us
Because
margin of
the
error.
Z star will change.
We're given
right.
margin of error and Z
Right, so
star.
here's how it works.
We're
Let me give
finding
you the
n.
basics of how it works, and then we'll put it into this example. We have learned the Garfield principle, right? When our confidence gets larger, say from 90 to 100, our confidence interval increases, and we're happy with that. That's like when you say the temperature is going to be between negative 200 and positive 200. We're 100% sure that huge confidence level is correct. So as the interval grows, so does our confidence in it. Now n, we've learned this way. If you increase n, which is the number of people in the sample size, when you increase that, you are zeroing in on the true answer. So confidence level shrinks. Remember that? The confidence level or interval shrinks as n gets higher.
That's not what's here.
All right, so now let's see what happens here. Here we kept the margin of error the same, and we increased the confidence number. So the confidence went up, so we would expect the number of people
To go up.
Go up.
to go up.
We did, and it did.
And it did. It went from 2,000 to 3,000.
Okay.
All right. So n got larger. And if you can't reason it, like I sometimes get muddled up in my thinking, the math will always tell you. So, all right. The poll was conducted through email. Explain how undercoverage could lead to a biased estimate in the case and speculate about the direction of the bias. So if they're only asking these questions to people with email, then they're leaving out everyone who doesn't have a computer or doesn't look at their computer or something. So, or doesn't have an email. So it does not include a lot of people and those people probably aren't very techy, and they're not going to be playing this computer game. So therefore, the population that they're going to get is going to be way overestimating the percentages because they are left out a whole bunch of people in that age group who don't use computers. All right, so let's go. Did you sketch in some questions?
Wait, what was the direction of the bias?
It overestimates the percentage.
So positive.
Because they were only looking at the people who had computers.
Are we turning these in?
No, they're study sheets. All right, so tell me what questions you have. I kind of just rattled out the answers except for that one.
Can you read your answer for A again?
On the last night
Number
ones.
1. Yeah.
On A, I said the parameter of interest is P, the percent of males aged 12 to 17 in the United States who play that game.
I think I have that.
You think you do?
Like I have words that are similar to that.
All right. All right. Other question marks? All right.
We got
These
this.
get better. It's like,
All right, I looked over the test and I found just a couple things I thought that we might look at. I think like 8 questions that we might look at that really hone in on concepts that the test also looked at. So if you could show these in video land, Joel, here's an extra one if you want to keep yours in your notebook. And just show them as we go over them.
can I have one for free?
Yeah, you're gonna see green.
I think so.
All right. Let's work these together so we can get through them. And I'll pause while you respond, and then I'll answer. So let's interpret. You have to be able to interpret what confidence means. So we've done a lot of it, but I put one more down. Interpret 95% confidence when the Europeans who favor gun control, that's for a sample, is from 88% to 96%, within a 2% margin of error. When I ask you to interpret confidence, how will you start your sentence, Maddie? All right, we are.
We are, yes.
Okay, so that should get you going. All right. Go ahead and read yours then, Maddie. What did you finish with?
We are 95% confident that the proportion of Europeans who favor gun control, true mean, will lie between 88 and 96%.
All right. All right, what'd you say after the word gun control?
True mean?
And this one is a proportion.
Oh, so it's just proportion.
Yeah, because of the percentage. Do you see that?
Yeah.
Okay.
So Europeans who favor gun control will lie between 88 and 96%.
Right.
Would it work if you just said true parameter?
Yeah.
that's what I
I
thought.
mean, they prefer that you actually identify it with the problem, the way she did.
So put the true mean instead.
No, it's the proportion.
Oh, the true
But you would have to say, we are 95% confident that you would, instead of saying, we are 95% confident that the true parameter P, or the true proportion P, is in this interval. But you want to state what you're talking about. So we are 95% confident that the true proportion of Europeans who favor gun control lies in this interval. So when you're taking the AP test and when you're taking a test, I let you fudge when you're doing homework, but just write it all out when you're doing it on a test.
So we should put true parameters?
Proportion.
Proportion.
Yeah, proportion.
Or mean if it's.
Yeah, or if it's mean.
Okay.
Now,
So what do you have?
I want to give you a precaution, and that is this.
Waiting for the next one.
Notice I asked for confidence. Did I say confidence interval? Did I say confidence level?
Yeah.
All right, so it doesn't say. So what they did on one of the multis is they had a question something like this, but the answer given was for confidence level. So just be aware that it could be the other way if I just say confidence. So let's also put a big or next to your last word. And would you go ahead and interpret that as if I did ask for confidence level? Do you remember what that meant? So here we have a population. We're looking for the true proportion of it. And it turns out that everybody did a sample, and you went up and back the margin of error. Some of yours were close to one another, some of yours were not. But all of them, except maybe one, actually captured the true proportion. Remember that day when we did that? So, this is talking about confidence level. Did you say, if many more samples are taken, 95% of the confidence intervals created will capture the true P, the true proportion of Europeans who favor gun control, if you want to add it again. Do you remember how confidence level works?
Can you read that one more time?
Right. And this one always starts, if many more samples are taken, then 95% of the confidence intervals, that's these, will capture the true parameter, true proportion.
So how do you know?
Which it is. This one I'm referring to is a multi, so you'll be able to, they'll list one of those answers but not the other.
Not both.
Yeah,
Okay.
so don't shy away from using, if they don't say confidence level or interval, be open to either, okay? Just a little warning. I rolled a 6-sided die as students in a large high school entered the building. When an even number was rolled, I asked the student entering what percent of homework he or she had completed before entering the building. 43 of the 200 students polled completed 100% of their homework. Check the conditions for constructing a confidence interval. So, do you know what initials to go after, Dan? What are we looking for when we check conditions?
Rin.
Rin tin tin. So go ahead and look at that example and see if it, first you want to know, it's helpful to know, are they looking for a proportion or an average, a mean? and then go on and do R, I, and N. If you find one that isn't, just for good practice, check the others. Of course, in real life, if it fails a 1, you're done. 1 is done, so. All right, there was an odd way of choosing the people who walked in the building, and that was not random. So I don't know if you could pick that up. Could you pick that up? That was not random.
Because it was a die roll.
I know, it looks sort of random in that you're rolling a dice, but it is not random. It's completely random, because every set will not have an equal chance of being chosen. So if you think that through, you'll notice it's not random. It is a process that involves a random process, but the whole choice of someone coming through the door is not random. So what would be a way you could do it randomly is, say you expect 2,000 students to come through the door. You assign them each a number. You choose ahead of time 200 random numbers, and then as they come in, you have to check their name against the number, and it would be very difficult to do. Yeah.
If on the test it doesn't say that it's like a simple random sample or anything, is it just safe to assume that it's not random?
Right. We pretty much have to say, at least question it. Like, I see no evidence that a random sample was conducted. All right, this one was not random. Independent, I asked you to check it anyway. So there was 200 times 10% rule. It's reasonable to believe that there was less, that is less than 2. It's reasonable to believe that 200 times 10 is 2,000 is less than or equal to a large number of students. So I'd say yes, assuming, I did say it was a large high school. All right, N for normal is, that's the one I erased over here. Here's one over here.
Val, are we pretty much always gonna pass the I?
I guess so.
Yeah,
But
like
the minute I said, no, we're not, so check it. I just remembered, I think it was either on the test or one of our practice problems for the test. On that, one of them failed. I tried, they only had like a 4 here, and it wasn't less, so. All right, NP is greater than or equal to 10. So usually, Dan, but once in a while, they'll try to trick you. All right, so putting the numbers in here, we had what, 43 out of 200 for the proportion. And the number in the sample was 200. The 200s cancel, and we get 43. So the other number would be 157. They do pass. All right, so random did not pass. In a sample size of 500, 175 use aspirin regularly. Find the standard error. Can you push me toward the formula that you're going to use for that one, Maggie? Which one?
Is it the square root of p hat minus 1 minus p hat?
Right here, this
Yeah.
one?
Yeah, the circle.
All right, so I circled it in yellow there. How do you get p hat, Joel, from that statement?
175 out of 500.
All right. If you tap that in, you get something like 0.35.
Yeah.
So under the square root goes 0.35, 0.65, and over a 500. Square root it. Do you get 0.021?
Yep.
Yes.
They love standard error, so be aware of that.
Be aware of the standard.
All right, this one I wanted to call your attention for.
0.02.
0.021. Find T star with 5 degrees of freedom with probability 0.2 to the right of T star. Now the part that you're used to finding T star with 5 degrees of freedom, but what's this stuff with probability 0.2 to the right of T star? So I want you to open to table B. You either have one floating around or it's in the back of your book. And this is something I failed to teach, because I taught you to look at the bottom and find the confidence level. and then the degrees of freedom, and I forgot to show you the top of chart B. So there's another way you can look at it, and it tells you at the top of chart B the upper tail probability, so you go along there. Of course the test is going to go in the direction I forgot to teach. Alright, do you see what I'm looking at? So, right, so you find there's another way to look at it if you don't know the degrees of freedom, or if you don't, this one does mention if you don't know the confidence level, you can use these numbers along the top. See that? So looking at that, this problem is pointing you to the point 2 to the right of T star. If you notice, table chart A looks like this. This is chart A. It's always to the left. Of course, when we go to chart B, this is chart A. Chart B gives you the value to the right. Does it matter? It doesn't, as long as you know what the chart is telling you. You can adjust for any question that comes down the line. But if you look at the top of chart B, does it color it in for you? Yeah, so you can see that it's on that side. On the other one's on this side. So, can you find the number now? Did you get 0.920?
Yeah.
Alright, just be aware that chart can be used
Wait,
in
where'd
that
you get that?
direction. Did you go?
Wait, where'd you
Point
get
2. Point 2 is right
that?
there.
I was looking at point 2.
Yeah, point 2.
Alright, so
and
then
then
it's
degrees of freedom,
5.
5. Alright? No other questions? Alright. Explain how a confidence sample can be constructed by altering the margin of error. Explain how a convenience sample can be corrected. I read that totally wrong. Alright, so suppose you messed up and you did a convenience sample. How can you correct that by altering the margin of error? The answer is?
Well, I have a question.
Yeah, okay.
Do you, isn't margin of error like not due to sampling error?
Yes, so no can do. Thank you,
Yeah,
Ryan.
okay.
You saved us some angst. What are some other uncorrectable sampling errors that you could do? Can you think of any other ones, Morgan, besides convenience?
Undersampling.
Undercoverage,
Undercoverage.
right? And not conducting it randomly. So we've already talked about both of those today. So those are, anytime you mess up with your sampling, this margin of error is not going to help you. What kind of error is it talking about? Do you remember? I told you one day.
This chapter?
Yeah.
It's an error in prediction,
It's called variability.
variability.
Yeah, so like every sample has a bunch of variables involved, so it's covering that. All right,
So-
number 6, go ahead and sketch a typical normal distribution. Just a regular, I gave you the z-scores between 0 and plus and minus 3 there. So above that, would you sketch a normal curve? So I'm expecting just the regular bell-shaped curve. Make it tall enough that you can fit 2 t's under it. 0, 3, minus 3. Alright, so there's my normal curve, so it's just a bell-shaped curve. Now relative to the one you chose as normal, mark it as normal. I'll call it Z for a normal curve. Go ahead and draw alongside or on the same graph a t distribution with 5 degrees of freedom, and then a t distribution with 15 degrees of freedom. Alright, so I'll do the t distribution, which has 5 degrees of freedom first. It's going to have a fatter tail, and it's not going to come up as high. when I say a fatter tail, it's going to be above the normal curve, like that. So say, let me make this one yellow. The Z one is the yellow one, the blue one is degrees of freedom 5 for T, is a T. So, how will the 15 fit in? Can you explain it in Maggie? How will the 15 fit in?
It'll have a like a thicker tail, and it'll be lower than the 5.
Lower, it's not. 15, the higher degrees of freedom, the closer it is to normal. So, it's gonna very closely mimic the yellow curve on the board, because it's almost gonna be the same, but not quite. So, remember, as degrees of freedom increase, it'll be closer to the normal curve. And now, I ask the question after that, which has more probability? A random selection from between -1, so here's my -1, right here, here's my +1. So there's the green section. Which has more probability? Suppose I'm going to make a selection from these 3 distributions. Which one has more probability of being selected? A random selection between -1 on the normal curve, or the T curve with 5 degrees of freedom, or the T curve with 15 degrees of freedom? So which one has a higher probability of being selected? Probability has to do with the area under the curve, so I'm basically asking you, between -1 and 1, which one has the higher probability? Do you see? The answer is the normal one, right? Because if I'm looking at this area, there's a bigger chance that I would get one from under the higher curve. And that is, the answer is the Z curve. All right, I'm closing on a house at 1 o'clock in Nashville, but I close here. So it's pretty cool. When you buy a house in another town, they just pick an agent in this area and they come to your house. So it's a very mobile world. So that's why my coat and stuff are sitting there. If you would finish these 2 and bounce the answers off of each other, number 7 and 8, I'm going to go over those before we take the test tomorrow. So you'll have the answers before. I don't want to make a whole video for just 2 problems. So when you come in tomorrow to take the test, I'll say, take out your review paper and let's go over the last 2. Then you'll take the test.
Should we leave the video on to
See the discussion?
so they can hear us discuss?
Yeah, it's okay.
Okay.
That's fun. Have fun closing.
What's that?
Have fun
Actually, I
closing.
can't do that. I need to take it so I can put it up.
Okay.
All right, so we will do the same for you. Should you come tomorrow, you probably won't be ready to take the test if you missed the review and we're sick. But if you are, we will give you the answers to those last 2 on the review sheet, 8A, and get you ready for the test. All right, sorry, I have to take it. Bye.